That's so fun. Love it. I want to use this.
This one says 13.
You're not supposed to forget anything, Maddie. Should I like write?
What's up?
Bar? What? Hex bar? Where? Oh, no, in front or at the end. It's how we write average, right? Add them all together and divide.
Wait, how do you get to?
How do you get average?
No.
How do you guys
Yeah. You add them all together and divide.
10.2. No. Let's get an 8.
All right. Do you really need me to show you how to find an average again? I guess I'm confused. You just add them together and divide.
How do you put it in the board? Say that again? I did.
The point estimator is the, how do I say this? So the actual statistic, like this number, that's your point estimate. The point estimator, I guess, is like the general form, X bar. So that you would say some is just like the statistic used to estimate the parameter. Oh no, I'm running into my joke.
It's so funny.
It is a funny joke. Have you read it?
Yeah.
And the point estimate is the actual value of the statistic. It's killing me, Smalls. Did I miss signing anybody's homework off? All right, so now we're gonna do our Hershey kisses. Oh, did anybody read the joke?
Haha, I laughed.
It was a 90% probability that I laughed, and I did laugh.
Whoa.
Seriously?
I was trying to understand it before I wrote it down.
All right.
Wait, going back to the front person.
No.
Okay.
I didn't even say it.
I laughed.
Thank you.
Yeah.
Who wants to read for me? Because as you can tell, my voice is hoarse today. Oh, thanks, Calvin.
In this activity, we will estimate a confidence interval for the portion of times a Hershey kiss lands on its base as opposed to the site. To do this, we will drop Hershey's kisses, count how many land on their base, and calculate the confidence interval. You take your sample, gather 5 Hershey's kisses in your cup, shake them up, and buffers from about 6 inches or less. Count the number that lands on the base, repeat 10 times to get a sample of size 50, recording your results in the table below.
Do you guys want cups? I have cups if you want, or you can just use your hands to tap them. Cups? No? Okay. So, just to clarify, that is not on its base.
That's insane.
That is on its base. Okay? So you're going to count the number that land sitting correctly on the base. Well, you're supposed to take 5, shake them, and drop from about 6 inches. I have 3. 1, 2, 3. So then I would write 3 for my first trial. You're going to do it 10 times. And here you'll have your p-hat, which is a total out of 50. So you'll add how many land on the base. I'm going to give you 7, which will allow you to eat some as you're doing your activity.
Yay!
We got 5 at a time?
Yes.
We do 10.
Mid? What was
Like this class
Oh, it's my favorite class now.
Was it not?
Yeah, seriously. I'm sad.
I know, where's
I got a 0.
Oh.
No better and no worse.
Thank you. Have an extra one.
Oh, look. I can't even reach it. You think I'm going to be able to grab
If
that?
anything, I'm actually going to do
There you go.
My first kiss.
Even 1.
Damn.
Damn!
I was trying to.
You know, you would think that there'd be a larger chance that I would land on his face, but not.
Thank you.
I suck at this.
I got 0.
Maybe it's because the best are good.
Again, 0s after 0s. Yeah, I'm not just saying with 0s.
How come? Toss it with that number that
Well, that was
every
my...
time I was going to try this dude. I love this brand. I kind of wanted to do chocolate.
Oh no, I broke it.
Where'd it go?
I got 13. Wow.
Ooh, I just got 3.
No.
Yeah.
It's like I'm gambling.
Got lots of zeros.
That's unfortunate.
Oh, I got 13 too.
Sounds like you guys are done tossing your Hershey Kisses. So two of you pick them up and drop them. No, we're not done. Okay, we're ready to move on. So what is the population that we're interested in estimating here? What was our sample? So you guys may have 0.26 like me. I got 13 out of 50. You might have something different. Usually in years past, I have kids sitting in groups. That's why it says the others in your group. But I'm just going to pick on 4 of you randomly to tell me your proportions. Maddie?
14 out of 50. Sorry, 0.28.
Thank you. Gosh, such a troublemaker, Maddie. Tyler? Who else do I want to pick on? Hayden.
0.32.
And Calvin.
0.34.
All right, so do.
It's okay.
Did we all get the same p hat? No. Sam and I got the same p hat. Anybody else get 13 out of 50? Amazingly, I didn't call on any of you. All right, so down below, we're going to follow the following steps to make our confidence interval. And it's going to be a 95% confidence interval. Now, remember that when you make a confidence interval, I kind of got in my own way with my underlining, but I'll put it off to the side. So a confidence interval, which I abbreviate as CI, comes from your estimate, which is going to be the proportion you got of kisses that landed on their base, plus or minus the margin of error. Today, we're working with proportions. So we're going to take p hat. Let's see. I'm going to write the word proportion. Proportion. we're going to take p hat plus or minus z star times the standard deviation of p hat.
Z star.
Yeah. Yesterday I called it what?
Z star.
So, yesterday we were looking at what? For our example, anybody remember? What? It was the mean. Yesterday we were looking at means. When we work with means, we use T star. When we work with proportions, we use Z star. They're pretty much the same thing. But you'll see more about T star when we get to means. So Z star, that means we're working with proportions. And then T star, that means we're working with means. Which, by the way, if we were to do a confidence interval for the means, it's very similar. Our point estimator would be X bar, like Anna showed us on the warm-up, plus or minus our margin of error, which would be T star times the standard deviation for X bar. Today, we're going to focus on proportions, so we're going to be working with this one. Now, just kind of like I've told you before, for whatever reason in math, we like to teach you the name for something, and then we get to a new topic, and we use the same thing, but we call it something different. Kind of like on the warm-up, really I was asking you to find the average, but we called it a point estimate. Here, the formula for the standard deviation for a sample proportion, I put 50 in because that was our sample size. They now all of a sudden call it the standard error. So if you see a question about standard error, it's just asking you to work with your standard deviation formula. So we're going to put p hat, which for me is going to be different than you unless you're like Sam or Molly. I can't remember who else said they had 0.26. So you're going to have a different p hat than me. So when we find our standard error or our standard deviation for p hat, we might have different answers unless you got 0.26 like I did. So excuse me. So I want you guys to find your standard error. Use your p hat that you got above. You do p hat times 1 minus p hat divided by 50 and then square root. So yours is going to be different than mine unless you got 0.26 like me. You could do it on your own, Sam. You don't have to copy me. What did we get, Sam? I have to take attendance, so I'm really going to wait on you to find it for us. Yeah. Anybody else need a calculator?
0.06. 2033. Yep.
0.06 what?
2033.
Okay, so we'll just go to 0.062. So, let's see. I'm gonna pick on somebody. Let's go with Shelly. What was your p hat?
No, 0.060.
What was your p hat to begin with? Sorry.
No, 0.24.
0.24. And then what did you get for your standard error?
0.060.
All right. So you may have something different than me unless you got 0.26 just like me. Now, like I showed you yesterday, Z-star can be found by looking at the thank you. I don't know why I'm struggling with words. Actually, I do because my voice sounds horrible, so I don't want to talk. I went too far. Back here, table B, down at the bottom, you have your confidence levels. We're working with 95%. So 1.96 is our Z-star. Now, like I said, you can also find it on the calculator. So I'm going to show you guys, actually, I'm going to remind you, you already know how to find it. We just never called it a Z-star. Anybody need a calculator before I go through it? No? All right. So, I'm going to draw a picture to go with it. So when, I can get through this. When we are finding our Z-star for a confidence interval, we're finding the middle percent. So if I'm looking at 95% confidence interval, that means I'm looking at the middle 95% of the data. Kind of like I showed you yesterday, which is why we added and subtracted 2 standard deviations above and below the mean. So 95% is 2 standard deviations above and below the mean. To find Z-star, we're looking for this Z-score right here, which you guys know how to find the Z-score given an area under the curve. The thing you have to remember is to find that Z-score, we have to include the area of that tail. What is the area of that tail? Say it again. 0.025 or 2.5%.
Oh, that's okay.
So really, when we want to find the Z-star for 95%, we use inverse norm. And we would include the 95% plus this tail for our area. So we're looking at 97.5% or 0.975 for the area. You'll leave the mean and the standard deviation as 0 and 1 when you're finding your Z-star. Because the way the calculator is written, well, let me take that back. The way most calculators are written is that it goes from where you want to find the Z-score all the way to the entirety of the curve. Some of the newer ones will ask about a tail, and if yours asks about a tail, you could do 95% and say you're looking at the center, and you wouldn't have to add that extra little part. But most calculators don't have that, so we need to just remember to add the extra little tail. I feel like Anna has my calculator that's going to ask about the tail, but most of them don't. Anybody remember where inverse norm is?
Second step.
No.
It's for
Second bar.
Second bars. Number 3. We have our area 0.975. You have to do a decimal or it's going to tell you there's an error. Leave the mean as 0, standard deviation is 1. And notice I get 1.9599, blah, 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 which when you round is 1.96. So if you're going to do 0.975, you would choose that. Those are not pretty easy.
Wait, do we know that, or are we just showing that to us to like prove it's 1.96?
You should be able to find any Z-star that asks you for. Because even though the book gives you some of them, I can ask you to do a confidence interval for an 8%, not just the ones in there.
I still don't get why you didn't tell though. That's, like, why would you have to add the,
Because what
if you're just trying to find
the Z-score, do you remember the formula for a Z-score? Because that's really what it's giving me is the Z-score for right here. Do you remember the formula for Z-score? I'm like, no, of course not. That was back in chapter 2. So we're in chapter 8.
Why do we
This
need
is
the
chapter 8.
Z-score?
Because that's what they call Z-star now. Z-score, Z-star, same thing. It's the critical value. Thank you.
I just don't want to
Why is that? Because mine was 0.26. So you had 0.34, so you should have 0.66. 0.34 times 0.66. Because you do P dot times 1 minus what? All right.
This is A slot,
So, inverse norm, it's just the way the calculator function is written. You have to give it the entire area under the curve to the left of the z-score you're looking for. It's just the way the calculator is written, unless it asks for the tail. Like on this one, when I do inverse norm, it asks for the tail. So I could say 0.95 and tell it that I'm looking at the center, 95%. And it's going to give me the lower z-score for the 95% and the upper z-score for the 95%. But most calculators aren't written that way, so you just need to remember to add the extra tail to the left. Because this z-score is the z-score for all of the tail to the curve to the left. So you just have to add the tail in. It's just how inverse norm works. It's not messed up. Back when I took statistics, the calculator didn't do it for you. You had to do a lot more calculations by hand. Back in my day, my voice matches the old person talk.
back when they had like black and white photos or everything and stuff.
Oh, I'm not that old. All right. So, just to have you guys practice one z-score on your own. You don't need to draw the picture if you don't need to help you find it. I want you guys to find the z-score, z-star, for an 80% confidence interval. So I showed you a z-star for 95% confidence. You do it for 80%. Just to make sure you know how to do it on your own without me up here telling you, like how to find the average.
Would be 85%. Because if you have 10 on each side,
Would that be 85? You kind of said it yourself.
9.
Oh, and each tail. Each, right?
So if it's 8, right? This is not 8
Okay, so if you want, if it's out of 100%,
That was that shoe.
then you split it into two left. How many,
Side.
one hundred, the other side,
Oh, that's one side, it's 9, right? That's the area.
It's like, okay, I felt like that. When I wrote like this, I'm like, okay, now how do we?
No, I thought it was.
It's just accepted.
Do we need the chocolate for any more days?
No. Would you like to go put the answer on the board for me? Tell your water bottle to be quiet.
No, I will.
Did you get 1.2?
What was it wait so long?
Literally both these. I don't
Hold up, go back up there. All right. Maddie, put the answer up. Do you have any questions for how she found it? She did great explaining it over to somebody else.
I just did.
Okay, what are you confused about?
all of it.
Okay, so if it asks you for 80% and you have to do the tail, you do 90 in your calculator because if you have 80%, each side's going to have 10% left to make 100.
Well, then why do you, okay.
No, is that what I'm
That
saying?
makes sense, that makes sense.
Okay, are you sure?
If it was 60, you'd have 20 on each side.
So then,
I imagine like whatever the number is in the
But do you
center.
add the tail into it?
yeah.
Yes.
Okay.
Whatever is just one. So it's like whatever like the center is, right? Then you have 2 sides divided by like add only one of them.
Thank you.
Because it's got to add to 100. So if you have 80 in the middle, at least 20 for the 2 sides.
Yeah.
So
And then
10.
and 10.
You
Or
have
Then you have to add one of them to then.
You add one of them.
Oh, it feels good to know what I'm doing.
It does feel good, doesn't it?
Really good.
So what she put in the calculator
What's that?
Ranzo tested.
is inverse norm with an area of 0.9, mean of 0, standard deviation of 1. And for you, because you're using the one that asks about the tail, you'd say left.
You just always put that?
Yeah.
Interesting.
All
So
right.
didn't she just do 0.8 and then put center though?
It was stuck out.
She could, yeah. But she may not always be using that one. That's the only calculator I've ever seen ask about tails.
Keep it on one.
And I don't know why that one does and not this one because they're the same.
Maybe that one's updated.
That's weird.
They're the same. I don't know why that one asks and this one doesn't.
Maybe you got
Anywho.
the newer version with newer firmware.
Now we have all the parts we need to make our confidence interval. Yours may be different than mine, okay? Because we each had a different p hat. Well, some of you had the same p hat as me. So you're going to take p hat plus or minus your z star, which we're working with 95%, so 1.96, and you're going to multiply it by your standard error. Here's the formula right there.
How do you know to plus or minus it?
You
Oh,
plus
lower
it to
and
get
okay,
your
right.
upper and minus to get your lower. So for me, my p hat, yeah. You get to just watch me do it. My p hat is 0.26. We all have the same z star. That stays the same. So that's 1.96. And then we each have a different standard error because it was based off our p-hat. So mine was 0.062. You'll have something different. What's up, Nate?
Is the 95% here arbitrary, or is it from something?
It's just arbitrary. I could have chosen any confidence interval to do this.
Is there a way that we're going to eventually have a confidence interval that we have to find?
Yeah.
Okay. No.
Why would you ask that?
What?
Yes. So when I do 1.96 times my 0.062, I get 0.12152. So I'm going to add and subtract that to get my confidence interval. When I add, that's my upper bound. When I subtract, that's my lower bound.
Whoa.
And then remember, we write our actual confidence interval like a point. So my confidence interval goes from 0.13848 up to 0.38152. And it looks like a point when I write it. Yes, sir.
We can go negative, right?
Yeah.
Can they go above 1?
Well, it'd be odd, but it could. You'd have to have a really big p-hat. But it could, yes. Can I flip? Of course there's more.
It's just when I finally understand a little chunk, I just like get lost right after that. So I'm scared.
Okay, well, Sam's done, so we're going to stop.
What if I just bring a hat that says PM?
Now,
No.
sure, that'd be pretty cool. I should get one.
You should.
A hat that just says P. It's my P hat. No, my rapper name is Soft D.
Oh.
Oh.
For Lynn. No. Okay. All right.
I don't like that. That's weird.
Now, what we're going to do is you guys are going to come draw your confidence intervals. So I'm going to show you how it's done. Down here, we have from 0 to 1. Your p hat, your point estimate, is where the dot goes.
Lower and upper.
See, we can keep going. Sam's still getting it. So my p hat was 0.26. So I'm going to do my best to estimate in between 0.2 and 0.3. My lower bound was about 1.4, which we're going to put parentheses, and then my upper bound was just shy of 0.4, 0.38. I didn't draw it very well. My dot should be in the middle. We're just going to make my dot bigger. You're going to have your own that you come up and draw. While you're not drawing up here, down at the bottom, I want you to interpret your confidence interval. I showed you how yesterday, so you should be able to do it today. I don't care if you use my sentence frames. You can use the sentence frame I showed you. I underlined the 3 things that would change from confidence interval to confidence interval. I should have you guys coming up here, drawing your little interval for me. Because, believe it or not, there is an actual parameter for how often the Hershey Kiss lands on its face. We're going to see how well we actually did. that 95% of our intervals actually capture.
I've done something very wrong.
Say that again?
I think I've done something very wrong, and I'm not really sure what. Yeah.
Dude, mine is very off.
Because you never know. It's the last one in the state, which
I copied on the wall.
So you would do 0.4 minus that.
I have a full schedule. You wanted to take
And then you would do 0.4 plus
Oh. Oh.
There's a lot more of you that need to draw your You don't need to draw them.
Oh.
You can if you want to. It'll reiterate what I tried to do last
0.3
time.
exactly.
You don't have to.
Why is mine so off?
Don't worry, Zach.
Oh yeah, there's no school.
Mine's
Friday.
way off.
1.7.
Which one's yours?
Mine's like 0.73.
I'm not, my grades aren't doing good.
Oh, I never said it was
So,
because of my grades. The grades are always so shit at mid-quarter.
You know, I was like, it was your failing like so many classes.
The person in the corner, my parents saw the report. and was like, why are you failing all your classes? And I was
so the
like,
way that
It's really bad. It's always
trust the process.
It really is. I feel like every AP student does that. Though.
Yeah, like I'm failing all my classes. Trust the process.
It's like, I'll have an A by the end of the quarter.
Okay, that is just how AP classes work, though. 'Cause They
Yeah.
only put like 1 grade in the freaking quarter.
If that.
I like how shit your line is. You use a ruler in everything, but it's like,
It's fine. It's a great line.
Come on, there's like 9 of you that still haven't done it. Come on. Come on.
There's no more space.
Come on. There is space. Put it in between.
Between where?
You could fit one in between the orange and the blue. You could just fit them in there.
It's not enough space.
You got this. Put it above this one. Put it below the numbers. Just get them on the paper.
Oh my. How do you really feel?
Very passionate
I am very
about
passionate.
interval.
Yes.
What the heck? Confidence intervals.
Of course I'm passionate. It's a math class.
Yeah. We should have a sport that involves math.
Yeah, come on, this is a
It's called math team.
Like physical math. Thomas does.
He's not old.
I don't do brain mold.
You do like the math.
I do math team. Well, I did.
3 years.
It's virtual. So it kind of petered off. When we go back to in-person, I'm sure they'll pick back up. You get to miss class to do math. How could you not? Samuel,
I am doing really good today.
you are.
Mine's an outlier.
All right. I know you didn't all come up here and do it, which makes me very sad.
Yes.
Who left their pen?
Ooh, that's a nice pen.
All right.
Oh,
So, like I said, there is an actual true proportion. They've done this many times where they drop the Hershey Kisses, figure out the proportion that land on their base, and the actual proportion is 0.3. So notice everybody's that came up here hit the true proportion. And remember yesterday I showed you with the applet that a 95% confidence interval would have about 95% of the intervals actually capture them. The only one is this pink one here. Just barely captured it, but we have 100%. Sam is going to come put the interpretation for us because he did a great job.
Yes, Sam.
If you haven't written the interpretation, make sure that you put it down. Yours will have a different interval unless you got what Sam and I got, because he and I got the same one. Do you have a question?
No stress.
I'm going as fast as I can.
No, you're fine. I hum and make noises. Now, a couple of people called me over and said, is this right? And they used yesterday's sentence frame, which was fine. But they had the true mean. We're not working with means today, so it should say the true proportion. But otherwise, it's pretty much the same. And then, of course, your interval, unless you got p hat of 0.26 like Sam and I did, you'll have a different interval.
Oh.
Any questions?
What if yours doesn't capture? Did you just say it does not capture?
No.
Yeah, who actually got on the?
So like if I got like
Yours captured it?
did it?
Yeah, the true proportion is 0.3.
Oh, okay, never mind.
It was actually
For
on
some
the
reason
dot.
I thought if the hat wasn't like really close to it that it wasn't.
No, it's the interval. All right. Down below, there are four sentences, 4 situations, 4 statements, however you want to say it. A, B, C, D. I want you to read through, true or false. If you think it's false, why is it false? If it's true, why do you think it's true?
Isn't A and B have to be the same thing?
Say that again, I'm sorry.
What's the difference between A and B? Will fall in or will include?
The wording.
So they're asking exactly.
Good job.
Guys, yeah, I don't know. It says eat a Hershey's Kiss while you ponder.
All right.
I already.
Hannah,
Yep.
will you say it louder, please?
Oh, they're all false because you're not supposed to use the word probability or chance.
Oh.
Genius.
They all say 95% probability. We don't use that language anymore. Or chance, like Hannah said. We say we're 95% confident. So they are all false. So, just like I told you last chapter, we will, do you have a question?
No.
Okay. We will focus on proportions and means in separate sections. So we'll start with proportions. We'll start section 8.28-2 on Thursday. We'll spend a couple days looking at proportions and how to do confidence intervals for proportions. Then we'll switch to the next section and we'll work with the population mean mu, and I'll teach you how to find confidence intervals for means. No matter what, whether we're working with proportions or means, there are going to be 3 conditions that we have to check before we can do our confidence interval. And I have this built into my lessons, but I want to introduce these conditions now. The first one is random. So the data has to come from a well-designed random sample or a randomized experiment. This condition is usually going to be stated in the problem. So those of you that hate reading the actual paragraph, it's going to be important to find that it says random or that they used an SRS, a simple random sample. So reading does become important. The next condition is normal. So our sampling distribution of the statistic is approximately normal. The sampling distribution of X bar is approximately normal if what? This was, I heard somebody say something, I think it was Maddie. What did you say? Oh, come on. Say it again, Maddie.
It's no more than 10% of the population.
Oh, no. I'll come back to you for that one in a minute. Say it louder, Hannah. More than 30. So, two things. If you're working with means, you know the sampling distribution is normal if your population distribution is normal, or if your sample size is greater than 30. I'm going to abbreviate distribution, sorry. The CLT stands for the central limit theorem. That's what tells us that if our sample size is big enough, our sampling distribution is normal. Now, if we're working with proportions, the sampling distribution of p hat is normal when what?
It's less than 10%.
No.
NP is greater than or equal to 10 when n times 1 minus p is greater than or equal to 10.
Thank you, Cheyenne. So for means, it's an or statement. Either the population distribution is normal or a sample size is big enough. For proportions, it's an and, so we have to show both those things are true. N times p is greater than or equal to 10, n times 1 minus p is greater than or equal to 10. And the last condition is independence. So individual observations are independent. When sampling without replacement, we must check, Maddie,
That the population is no more than 10%.
the sample size is no more than 10%. So your sample size, little n, has to be less than or equal to 1/10 of the population, so we can use our formulas for standard deviation. Like I said, I'll show you how to check those in my lessons coming up, but I wanted to bring them to your attention now. Can I move it up? It's not confusing. It'll just become a checklist you do.
Like sauce.
Kinda, yeah.
Or bins.
But it'll be, I suppose you could do R-I-N, so rin,
Right.
or you
Ner.
could do ner. I
Or
kind of like ner
earn,
more.
Earn.
Earn. But,
Earn that money.
oh, see, you said earn, and I guess because I'm old, it makes me think of what they keep ashes in.
Oh.
I'm like, I don't like earn. Oh, goodness. All right, so a few cautions.
That's gruesome.
Our method of calculation assumes that the data comes from an SRS of size n. What does SRS stand for again? Our methods will not work if you're looking at a stratified or cluster sample. Yeah, we did forget about those, huh? cluster? Anybody remember? No.
Cluster sounds like a mess.
Michelle.
Wait, I can't remember which one was which. I remember one is like the whole population and one is like just a section of the population.
Cluster.
So stratified, you would break up the population based on, I always think of like a high school, probably because I teach at a high school. If we broke you guys up based on your grade level, and then we took a sample from each grade level, that's stratified. We broke you into groupings that were similar for you. So your grade level, that's a strata. A cluster would be, and this is hard at a high school, if I could put you guys into classes where you mirror the population, so it's a mixture of freshmen, sophomore, juniors, and seniors, and then I pick random classes, that's a cluster sample. That one's harder to explain with a high school.
Did you like the last time?
Yeah, that's the only class I can think of that has all levels.
What about band?
What?
Yeah, but band is not,
I mean,
I don't think band mirrors the population well.
That's fair.
Right? Thank you. It doesn't mirror the population well. There are the music people and the non-musical people. I'm not musical. Henry is musical. My youngest, he is musical. That kid is... All right. And then last thing, the margin of error in a confidence interval covers only chance variation due to random sampling or random assignment. It does not cover variation due to other sources such as non-response or undercoverage. Any questions? Oops. Okay, I heard wait, so I'll wait.